Hello friends, I am Dr. Poonam Bora. Let us study inverse transformation. The definition is, for a point z equal to xy in the z plane, the relation w equal to 1 upon z defines a corresponding point w equal to uv in the w plane. We call this as inverse transformation. Let us obtain the relation between xy of z plane and uv of w plane under the inverse mapping w equal to 1 upon z. For this, we substitute z equal to x plus iy and w equal to u plus iv in the equation w equal to 1 upon z, so that we have x plus iy equal to 1 upon u plus iv. Multiplying and dividing by the complex conjugate of the denominator on the right hand side, u minus iv, we get x plus iy equal to 1 upon u plus iv into u minus iv upon u minus iv, which on simplification becomes u minus iv upon u square plus v square. Separating the real and imaginary term on the right hand side, we obtain x plus iy equal to u upon u square plus v square plus I minus v upon u square plus v square. Equating the real and imaginary parts on both sides, we get x equal to u upon u square plus v square and y equal to minus v upon u square plus v square. Note that the relation x equal to u upon u square plus v square and y equal to minus v upon u square plus v square will be used in further discussion. We also need to know that the equation x minus h whole square plus y minus k whole square equal to a square represents a circle with center hk and radius a. Let us understand this example. Find the image of the infinite strip 0 less than y less than 1 by 2 and x greater than 0 under the transformation w equal to 1 upon z. First, the infinite strip 0 less than y less than 1 by 2 is as shown below. It is the region bounded by the two straight lines y equal to 0, that is the equation of x-axis, and another line y equal to 1 upon 2. Both these lines are bounded by this region, and this region is the infinite strip whose image needs to be found out under the inverse mapping w equal to 1 upon z. We will obtain the image of this infinite strip in fragments. Firstly, we obtain the image for the strip 0 less than y. Then we proceed for the strip y less than 1 by 2, and then we combine the two results. As I said earlier, let us denote this relation by equation 1 and equation 2. Let us consider the left half of the given inequality 0 less than y. That is, y is greater than 0. In other words, 0 less than y is nothing but y greater than 0. As shown in the figure, it is upper half of the z plane. In this half, y is greater than 0. In the lower half, y is less than 0. Right now, we are finding the image of y greater than 0 under 1 upon z. Using the value of y from equation 2 in the inequality 3, we get minus v upon u square plus v square is greater than 0. Now we multiply both sides of this inequality by u square plus v square and we obtain minus v is greater than 0. Now we multiply both sides of this inequality by minus 1 and on doing this the inequality sign will reverse and we get minus 1 into minus v is less than 0. That is, v is less than 0. Thus, for 0 less than y, the inverse image is v less than 0. This is the portion below the line v equal to 0, that is below u axis. Thus, the image of y greater than 0 under 1 upon z is v less than 0. So, it is the lower half of the w plane where v is negative. In the upper half of the w plane, v is positive. Now consider the right half of the given inequality, y less than 1 by 2. Let us denote it by inequality 4. This is the line y equal to 1 upon 2 and obviously the region below this line is the region y less than 1 by 2. Again, we know that y equal to minus v upon u square plus v square. Using equation 2 in the inequality 4, we get the image corresponding to y less than 1 by 2. Minus v upon u square plus v square less than 1 upon 2. Multiplying both sides of the inequality by 2 into u square plus v square, we get minus 2v less than u square plus v square. Now adding 2v on both sides, we get 0 less than u square plus v square plus 2v. We tried to make the right hand side a perfect square. So we go for half into coefficient of v whole square, that is equal to half into 2, which is the coefficient of v, and we take it as a square. So we obtain it as 1. Thus we add 1 on both sides of the inequality and we obtain 1 is strictly less than u square plus v square plus 2v plus 1. That is 1 less than u square plus v plus 1 whole square. Rewriting it as 1 less than u minus 0 whole square plus v minus minus 1 whole square. Comparing RHS with left hand side of the equation, x minus h whole square plus y minus k whole square equal to a square, which is a circle with center hk and radius a. We see that the RHS of the inequality is a circle with center 0, minus 1 and radius 1. The inequality represents exterior of the circle u minus 0 whole square plus v minus minus 1 whole square equal to 1. That is the region which is outside the circle with center 0, minus 1 and radius 1. The exterior of this circle is the image of y less than 1 by 2. Thus the image of the infinite strip 0 less than y less than 1 by 2 is combination of both of the above individual cases. It is exterior of the circle as discussed above. Thus the infinite strip 0 less than y less than 1 by 2, that is this region under the mapping 1 upon z, is mapped to the region which is exterior to this circle . Now let us discuss the second problem, wherein we are supposed to obtain the image of x greater than 0 under the inverse mapping 1 upon z. So x greater than 0 is the right half of the z plane, wherein x is positive for any number, whereas the left half indicates x less than 0. That x equal to u upon u square plus v square when w equal to 1 upon z. Using equation 3, in x greater than 0, we obtain its image u upon u square plus v square greater than 0. Multiplying both sides of the inequality by u square plus v square, we get u greater than 0, that is portion to the right of uv plane as shown in the figure. The portion to the right of uv plane is the image of x greater than 0 under 1 upon z. Thus the region x greater than 0 under 1 upon z is mapped to u greater than 0. For more examples, we'll come up with more videos. Thank you.